Today we are exploring the inverse element of binary operations. If two elements are combined under an operation star to produce the identity element E, then one element is the inverse of the other for that operation. In other words, an element A, star its inverse denoted by A raised to -1, will result in the identity element E. Note that the order can be reversed and the result is the same. Let's take the binary operation of addition. We know the identity element for addition is 0. So what number added to 5 will give us 0? The answer is -5. That means -5 is the inverse of 5 under addition. Likewise, 5 is the inverse of -5. In general, for any integer a, the additive inverse is -a. Now let's look at multiplication. Here, the identity element is 1. So the question becomes, what number multiplied by 5 will give us 1? The answer is 1/5. This means that 1/5 is the inverse of 5 under multiplication, and 5 is the inverse of 1/5. In general, for any non-zero number a, the inverse under multiplication is the reciprocal, or 1 over a. Let's try an example with a custom-made binary operation. An operation star is defined on the set of real numbers such that a star b equals a plus b plus ab. Determine the identity element. Find the inverse of a. Find the inverse of 5. State the element that has no inverse. To find the identity element e, we use the fact that any element a combined with e should leave a unchanged. So a star e equals a. Substitute e for b into the equation, and we get a plus e plus ae equals a. Subtract a from both sides. Now factor e from both terms on the left-hand side. Divide both sides by 1 plus a, and we get e equals 0. To find the inverse of an element a, we use the fact that an element a, operating on its inverse, will result in the identity e. So in the binary equation, we replace b with a inverse to get this equation. Recall e equals 0. Now group a on the right to get minus a. Now factor a inverse from both terms. Divide by 1 plus a. So the a inverse is minus a over 1 plus a. To find the inverse of 5, we simply replace a with 5 in the inverse of a formula that we derived in part b. So the inverse 5 is -5 over 1 plus 5, which is -5/6. To find the element that has no inverse, we go to the inverse formula again. Note that you won't get an inverse if the denominator 1 plus a is 0, since it will be undefined. Solve for a, and we get -1. So -1 has no inverse. An operation delta is defined on the set of real numbers such that x delta I equals x plus y minus 8. Find the identity element e. Find the inverse of the element x. Find the inverse of 3. To find the identity element e, we use the fact that any element x combined with e should leave x unchanged. So x delta e equals x. Substitute e for y into the equation, and we get x plus e minus 8 equals x. To solve for e, we group all the terms to the right-hand side except for e. So we get e equals 8. To find the inverse of an element x, we use the fact that an element x operating on its inverse will result in the identity e. So in the binary equation, we replace y with x inverse to get this equation. Now group everything on the right-hand side except for x inverse. So the inverse of x is 16 minus x. To find the inverse of 3, we simply replace x with 3 in the inverse of x formula that we derived in part B. So the inverse of 3 is 16 minus 3, which is 13. In this example, the binary operation is defined by a table. Before we can determine the inverse of each element in the table, we first need to find the identity element E. To identify the identity element, we simply find the row in the table that is identical to the top row. That's the bottom row. So the identity element is 4. Notice that when 4 operated on each element in the set, they remained unchanged. To find the inverse element, recall that an element A combined with its inverse should result in the identity element E, which we know is 4. So we simply look at the elements that combine to give 4. 1 star 1 is 4, so the inverse of 1 is 1. 2 star 3 is 4, so the inverse of 2 is 3. Also 3 star 2 is 4, so the inverse of 3 is 2. While 4 star 4 is 4, so the inverse of the identity number 4 is itself 4. In the final example, the binary operation is also defined by a table. Before we can determine the inverse of each element in the table, we first need to find the identity element E. To identify the identity element, we simply find the row in the table that is identical to the top row. That's the third row. So the identity element is B. Notice that when B operated on each element in the set, they remained unchanged. To find the inverse element, recall that an element A combined with its inverse should result in the identity element, which we know is B. So we simply look at the elements that combine to give B. A star A is B, so the inverse of A is A. B star B is B, so the inverse of B is B. C star D is B, and D star C is also B. So C is the inverse of D, and D is the inverse of C, since the identity element is the result when they operate on each other. Thanks for watching. Hope you found this video useful. Remember to like, subscribe, and share. See you soon.